Let's dig deeper now into Apex testing. Let's first understand what it actually means over here. Apex testing is the process that helps you create relevant test data in the test classes and run them in Salesforce. So what Apex testing lets you do is that whatever class that you have created, you create a test class for the same class in which you have got different unit tests, with the help of which you execute you execute the execution of that particular class, and you give different inputs, and based on to the different inputs you verify whether the output matches the expected requirement or not, and if it matches it, you just pass the unit test, and if it doesn't, then you just fail it. So that's what happens, right? This is a test class and this is a class, right? And now let's go on. Positive behavior. Okay, so as a part of Apex testing, you need to test for positive behavior. So what positive behavior means is that whether the input that you're giving, based on that, the class is returning the expected output or not. So like, let's say if there is a function with the help of which you are adding two numbers. So what you want to verify is that if you have given 3 and 5 as an input, whether it is giving 8 as an output or not. So that's a positive behavior that you need to test while testing. Next thing is negative behavior, right? This basically means test the limitations of the system if a negative value, unexpected value or input is provided to the Apex code. So for what I mean by that is, so let's say you need to add two numbers. That's the code that we tested earlier for the positive behavior. Now testing it for negative behavior, we can pass a number which is like integer, which is an integer, and another number as an integer, but the addition of both of these numbers will result into that integer being more than the range of an integer. So like, let's say there is the range of integers is like something 217843221, right? Something like that. I'm not exactly sure what that number is, but let's say that you are giving such a number, or let's say the range of integer, let's say, is 1 to 100 or minus 100 to 100, and now what you're doing is you're giving a number 60 and another number as 70. So it will result into what? Which number? 130, which is more than the range of integer. So this is something that you also need to test in the Apex testing or in the unit test cases, which you'll be creating in the test class. So, and this is something which you call as negative behavior testing, right? So again, first positive behavior and then the negative behavior testing. Next, restricted user. So in this, you have to test whether or not the program or the application is working for a user which should not have access to this particular code or to this particular application, right? So that's what it says. So check that a user whose access to certain objects or records is restricted is barred from accessing them. So like, let's say there is a user who cannot create any record for account object. But with the help of your code that you have written down, it is able to create account records. So it's bypassing the security and sharing settings that are applied, which are applied onto the onto the profile level or onto the permission sets level. So this is something that should not happen. So you need to test for that as well, and whatever test cases gets failed, you just need to flag those test cases to the developer in order to update the code of the class so that the code is working fine for all the positive test behaviors, all the negative test behaviors, as well as for the restricted users access as well. Now there are some points related to Apex testing which we need to understand or which we need to learn before moving ahead and creating our own test class for a class or creating our own unit test cases. Let's have a look. Okay, so Apex provides a testing framework that allows you to write unit tests, run your tests, check test results, and have code coverage results. Okay, so this developer console in itself has got its own testing framework, so you do not need any other testing framework in order to test the code which you have written down into Apex, and it allows you to execute the test cases, run the test cases, see the results of the test cases that you have executed, and it also shows you the result of the coverage or the coverage which the test class covers. And that basically means, like, let's say if there are 100 lines in a code or in a class, and while executing the unit test cases, how many lines are getting executed while we are executing the test class, right? So that's something called as code coverage. We'll understand it on a deeper level later on as well, but this is something that also which you also see as a result of testing inside this particular framework. Next is testing is the key to successful long-term development and is critical component of the development process. It is strongly recommended that you use a test-driven development process, that is test development which occurs at the same time as code development. So what this basically means is that without testing, no code development or no application development should happen, and it should happen alongside, right? And what that basically means is that it should not happen like you have created a complete code or a complete application which has got multiple classes, multiple different type of triggers, multiple many different functionalities that you have created, and at the end of it, it should get tested. It should happen alongside that. Whenever a new class is getting created or new functionality is getting created, there should be you should have the test class for that same thing along the development process. It should not happen at the end of the development process. That is exactly what we are trying to say over here. Next, testing is the key to success of your application, particularly if your application is to be deployed to customers. If you validate your application work as expected, that there are no unexpected behaviors, your customers are going to trust you more. It's very simple. The quality of a particular product determines the brand value of the company which is generating or which is creating that particular product. So like let's say when it comes to cameras, or the camera that I am using, why do we trust Canon for it? Because I'm using a Canon. Because it has created a brand value by providing quality products to the end users. And who are the end users? The people who are the photographers, who are videographers, and who are using it day in, day out for their job. So if there will be some error into Canon cameras, then these end users are going to avoid using it, and hence the brand value will get decreased, and hence there will be no more cameras that Canon will be selling. So now you can understand how much testing is important, even if you are a part of a company which is delivering an application to the end users, or part of the company which is creating its own product and catering that product to the end users. It is very, very important for you to make a defect-free application or a defect-free software. So it's very, very crucial. You should not downplay it or underestimate it basically. Now, next is, there are two ways of testing application. One is through the Salesforce user interface, which is important, but merely testing through the UI will not catch all the use cases for the application. So again, this is manual testing, which we discussed earlier as well. And the other way to test for bulk functionality through your code, if it's invoked using SOAP API or by Visual Force standard set controller, stuff like that. So if the simple way, which is important, is manual testing, which you can do by just going to the UI and doing some stuff. But you need to test your code for the bulk data operations as well, and for different API callouts as well, if there are any, or different code that you have written down. So in order to test that, we all need to automate the testing. And how will be automating it? By the help of writing down unit test cases in the test classes. Okay, so one more reason, and a very, very important reason why we need to write down test cases, and this is something that you should know very, very well, that why exactly we should write down test cases or test classes for the Apex code that we are writing down is this. So before you can deploy your code or package into the Force.com app exchange, the following must be true. So if you're trying to create an application which will be deployed into the app exchange marketplace, where the application will be downloaded and will be used by different companies into their orgs, you should at least have 75% of Apex code which is covered by unit tests, and all of those tests must complete successfully. So what that basically means is, like, let's say you've got a class which you want to deploy into an app exchange application, or let's say into your production environment as well, and it has got 100 lines of code, right? I'm just using 100, but the number of lines that it will have are going to be definitely more than that if you're creating a good functionality into it. So let's say there are only 100 lines of code which is written into class A, and now what we need to do is we should at least cover 75 lines of code into this particular class in order for it to be deployed into an App Exchange application or into the production environment. And why 75%? Because there is some code that cannot be tested, or yes, there can be some code which is difficult, or there is some code which we cannot test, or which we cannot execute while executing a test case. So that can be exempted, or yeah, that can be avoided. But your code should have at least 75% of code coverage. And what that means is that at least 75 lines out of those 100 lines in that particular class should be covered by your unit test cases, or should be covered by your test class. Okay, and it's not like that you can write down test class or unit test cases just to cover 75 lines of it. If you can cover all the lines of that particular code, you should not avoid it. You should try to make the code coverage as much as possible, right? Because if you'll be deploying it into an App Exchange application, your complete code coverage will be calculated, not for a particular class. So you should try to like maximize the code coverage, and you should try that if you can execute the test case for all of those 100 lines, you should do that. And in fact, the code coverage is not the only thing because of which you should write down the test classes or write down the test cases. Listen to this very, very carefully. There are a lot of Salesforce developers that I know. Unfortunately, some of them are trained by me as well, who only write down the test cases or the test classes just to make sure that the code coverage is 100% or more than 75%. They do not actually test it the way it needs to be tested. And how it needs to be tested is basically what gets defined by the kind of test cases that you're writing down, and not only by the kind of test cases that you're writing down, but the quality of the test cases that you're writing down as well, and how many scenarios or situations you are covering up into those test cases. You should actually do the testing. You should not do the testing to just reach this code coverage benchmark. You should do the testing in order to make an application or a code defect free. So that's what should be the motive of writing down the test classes or the unit test cases, instead of making sure that the code coverage is greater than 75%. So yeah, but this is a very important aspect again. Every trigger must have some test coverage. So in triggers, it should have some test coverage. It's not like that you should have 75% or something like that, but it should have. But if you can, again, same thing. If you can cover it all up, better. All classes and triggers must compile successfully. Again, this is a basic requirement. And when I say 75% of code coverage should be there, it also attach another condition, which is all the test cases that you executed should pass. There should not be any single one test case which should be failed while executing the test cases, or while executing the test class, or while executing the test run. If there will be any single unit test case that will fail, you'll not be able to deploy it. So you need to make sure that the code coverage is as maximum as possible, and also all the test cases that you have written down are being passed, or are being passed. Next, Salesforce run all tests in organizations that have Apex code to verify that no behavior has been altered as a result of any service upgrade. Okay, Salesforce again. Okay, so Salesforce and by the way, whenever you deploy the class into the production environment and stuff like that, all of the test cases gets executed in order to verify that there's nothing that is creating a problem inside another org while deploying that particular class into that particular org. And if there is a problem, then it doesn't get deployed. So that's what the case is. Note some following. When deploying Apex to production organization, each unit in your organization's namespace is executed by default. So each unit test case is what this means. So every test case that you've written down for that particular class will get executed automatically whenever you will be deploying that particular class into another org. And when those test cases will be executed over there, there will be different positive behaviors, negative behaviors, and I don't know what all behaviors you have tested in the unit test cases. All should get passed in order for that class to be deployed into the production environment. Calls to system.debug are not counted as part of code coverage. Again, I mean, if you're writing down system.debug anywhere, that line is not even considered as a part of code coverage when it comes to calculating the code coverage for test classes. Test methods and test classes are not counted as part of Apex code coverage. So again, test cases and test classes are not counted against the limit of code that you can write down into a particular org, which is I guess 3 MB for developer edition. But yeah, this is something, and again, for a class, there is test class that we have written down, which will make sure that there is a test class that we have written down, and which will finalize the code coverage for the class. But there should not be any code coverage for this unit test cases or test classes, right? So that's what it is. I hope it makes sense.